Hey everybody, Mr. Gibson here. So for this activity, it's an elaborate activity. So what that means is we're going to dive a little bit deeper than necessarily what you would be asked about on a quiz or a test, but hopefully it will kind of enrich your knowledge of biology. And specifically, we're going to look at how neurons work, neurons being your nerve cells, and specifically how they work in terms of homeostasis, or remember that balance in the body. So remember that every cell in your body maintains homeostasis. It's not just your whole body, but it's every cell in your body, okay? And nerve cells are no exception. They also have to maintain a balance. And they have to maintain a balance of what's called ions. Now, you may have learned about this in a previous class, but if you haven't, or if you don't remember, ions are when an atom has an electric charge. So, for example, like a sodium atom can have a positive charge, or a chlorine or chloride atom can have a negative charge. Okay, and potassium can have a positive charge, and those are really the big ones that we're going to see today. Those are the ones involved with your nerve impulses. Okay, so when an impulse moves through the chain of nerve cells, so for example, like if your brain is telling your hand to move or something like that, the signal has to be passed. The impulse has to be passed through a series of nerve cells. They will transfer ions from one cell to the next to act as kind of chemical messengers, okay? And the cell, after the ion amount has changed, has to quickly reset the balance of ions so that that nerve can be used again to send another signal. If this didn't happen, if that balance wasn't restored, then your nerves can only be used once, and that wouldn't be great. So what you guys are investigating today is how long does it take a nerve cell to return to homeostasis for ion concentration, or how much of each ion are on either side of the cell after a nerve impulse moves through it. Okay, so that's what we're trying to figure out. How long does it take your nerve cells to return to homeostasis after a signal has been sent through them? This is pretty interesting, I think. So what you're going to want to do first is make a prediction, okay? And it's totally okay if your prediction is wrong because you haven't done the experiment yet. So make a prediction about how long you think it takes. Just throw a number out there, whatever you think is a reasonable number for how long it takes for your nerve cells to return to homeostasis so that they can send another signal, okay? And then you're going to follow the procedure. Now, while you're doing this, and I'll have this linked in the assignment, you need to have this simulation pulled up, okay? This is showing a nerve cell, and it's showing the outside. Remember, your nerve cells are really long, so it's showing the outside of your nerve cell. And then we got a cross section here so we can see the inside. And if you zoom in, you can see all these what are called ion channels, which are basically just little holes in the cell membrane for the ions to flow through, okay? What I would advise doing is turning on charges, turning on concentration, and wait for the chart. But especially have on concentrations, because that's really what we're trying to see here is how much of each thing is on each side, okay? So we've got the amounts of potassium and sodium on the outside of the cell and the amounts of potassium and sodium on the inside, okay? Now let's go back here and follow the instructions. It says this procedure will require the use of a timing device. So I will link an online stopwatch. It would probably be easier for you just to use your phone stopwatch, but if you don't have access to that or don't want to use it for some reason, you can just use the online one that I've linked. Okay, so you're going to open the simulation and check concentrations. So you want to make sure to have concentrations checked. Even if you don't have all of that checked, you need to have concentrations, okay? Then you're going to record when it's at homeostasis. So you haven't done anything. Right now it's at balance. You're going to record the homeostasis concentrations of potassium and sodium. So these are the normal levels, okay? So right now the normal level of potassium would be, you can choose inside or outside for this. It doesn't really matter. Let's do inside. So it would be 140 and then the normal level of sodium would be 10. Okay, so 140 and 10. And so you'd put that there, and then you get your stopwatch ready, and then you click Simulate Neuron, and you start the stopwatch as soon as you click it. So this is where it's really easier to use your phone. So we're going to hit Stimulate Neuron, and you're going to see that impulse moving down the neuron. Okay, and you can see all these ions are going crazy now. Okay, so as soon as the ion concentration returns to homeostasis or back to those original levels, you're going to stop the stopwatch and record the time that it took in your data table, which is on, it's right here below. Okay, then you're going to repeat those steps 3 more times and average that time together. Okay, you're going to then write a conclusion about how long it took, and then you're going to answer this extension question. Okay, so hopefully that makes sense. Again, this is going a little bit deeper than you necessarily need for the quiz or test, but in biology, we're learning things because they're interesting and because they're applicable to us, not just because they may pop up on a quiz or test. So hopefully this will kind of enrich your understanding of homeostasis and how neurons work. If you guys need any further assistance with this, please let me know. All right, good luck, guys.